Hi, this is Gilles, the radio prepper. I get a lot of questions about radio range. How far can you reach with different types of radios? So if you have friends, family that you'd like to make contact with, that may be in the next town over, maybe the next state, a different country, or even a different continent, this video is for you. I will cover amateur type radios, but also radios that do not require a license. You might want to pause the video now and get a piece of paper and a pen because you're going to learn something today. I first need to lay down some bases and definitions before we get into different types of radios and frequencies you might want to use. So bear with me, I'll make this as painless as possible. If there is one thing that you should remember about range is that it's not set in stone. Sometimes, you're using one of these little handheld radios. One day you're going to go to a quarter of a mile and the next you're going to go to 200 miles and you just don't know. There are so many factors that can change how far your radio is going to reach. I remember once a friend of mine was using a very small handheld radio and it outputted, I think, 100 milliwatts. Now, 100 milliwatts is 5 times less than the cheapest, FRS little radios that you can get. And yet, he made a 200-mile contact with it. Now, we were at about 2,000 meters altitude. So, I don't know, 6,500 feet or something like that. So, the height was a great factor, and also the fact that it probably went through some ducting propagation. We'll talk a little bit about that, don't worry. So basically it was refracting between a temperature inversion and the surface of the ocean. And he made a 200-mile contact with 100 milliwatts. So some days with the same radio, it will go a quarter of a mile, a few hundred yards, because you have obstacles in the way. So range is not something that you can easily predict. You can have a bit of an idea, and you can use antennas and radios that will get you, and techniques that will get you the range that you need. And that's what we're going to see in this video. Radio range depends on a lot of factors. For instance, you have the frequency you're using, so how many cycles the current goes up and down per second. That can make a great difference. And for instance, you have frequencies that will penetrate materials better, and you have other frequencies that will bounce around easier. Also, you have, of course, obstacles again. So anything that's in the way of that path between you and the station you want to contact will be a problem because the radio waves don't penetrate easily through material. Which brings us to height above ground. Of course, the higher you can be, the better, because you go over the obstacles. Then you have propagation. Propagation is the way that radio waves go from point A to point B. And they can do that in a few different ways, and we'll see about that. Also, the type of antenna that you're using. Some antennas will send a signal all around the same way, and some antennas can actually beam the signal in a particular direction. So of course, if you take that volume of radio waves and you squeeze it in one direction, you're not amplifying the signal, but you are going to send it in a particular direction and not the other. So it kind of looks like you're amplifying the signal, but basically you're just redirecting the waves, and some antennas can do that. Something that a mistake that beginners often make is to think that more power is always better. And that's definitely not the case. I would never suggest to anyone to buy a radio based on output power. Power is one factor, but it's not the most important. Then that gets a little bit more complicated. You have modulation mode. There are different ways to code information, basically, be it voice or digital information. And the way you code that information can affect the range of the radio. All right, so I needed to make some definitions about range because I'm going to talk about different ranges and their they require different radios and antennas and stuff. So at the bottom, you have, of course, local, which means, your area, your town, and that's probably within 10 miles. And that's generally pretty easy to obtain. Then you have 2 regional ranges. Regional, of course, your region may be up to your state if you're in the US, something like that. So you have near regional, it's my own definition, what I call near regional is from 10 to about 100 miles. And that's fairly difficult, believe it or not. It's actually easier to make a 1,000-mile contact than it is to make a 200-mile contact. So we'll see why that is. But near regional, 10 to 100, and then you have what I call far regional, which is 100 to, let's say, around 500 miles. And then, of course, you have the global range, which is the whole planet, also meaning going all around. And yes, it's possible, even if the radio waves go in a straight line, it's possible to actually go around the globe. All right, so first frequencies. Frequencies are divided into different bands because they have different behaviors. You have the HF band, which is also called shortwave, and that's from 3 megahertz to 30 megahertz. That encompasses CB and all the shortwave bands for radio broadcasting. So it used to be, called HF high frequency, but of course today it's no longer the highest. So before we didn't have the electronic components to go very high in frequency. So HF is the bottom band, so to speak, as far as frequencies go, and it has a lot of advantages. Then we have VHF. VHF is often used in these little walkie-talkies, and it's from 30 to 300 megahertz. So usually if you go for, with a radio like this, it's probably going to be around 144 to 148 megahertz, something like that. Then you have UHF, I'll talk about it. But VHF is basically the middle of that band, between 30 and 300 megahertz, so 140 something. That's usually what we call VHF. On top of that, you have UHF, ultra high frequency. Now, VHF was very high frequency. UHF is ultra high frequency, and it goes from 300 megahertz to 3000 megahertz, which is 3 gigahertz. And that also usually is available on radios like this, as well as the FRS radios, Family Radio Service in the US, and things like PMR in Europe, GMRS in the US again. Those are generally in UHF, and they have advantages also, and they have drawbacks. I'm not going to talk about the frequencies above UHF. We'll stop probably at 400 some megahertz, because it's really not common, and then you have a whole lot of new problems that come into play, so it's not something you're going to be using. We could go up to I'll talk about Meshtastic, for instance, which is on either 868 or 915 megahertz, but usually we'll stay in the lower UHF. So 3 bands: HF, shortwave, VHF, UHF. One thing to consider is that lower frequencies penetrate material better, and higher frequencies bounces off material better. So, for instance, you could have a cliffside, and depending on the type of rock it's made of, you could bounce a signal on a cliffside to reach someone further away on the other side of a hill, for instance. And that's possible. On the other hand, if you're in a forest, for instance, because the plants, the trees are grounded and they are somewhat conductive, you would have a very hard time to get a signal out of a forest, for instance. And that's where lower frequencies will penetrate better, but not always. I mentioned the height above ground, and that's a very important factor in radio range. The higher you are, the better. And that's probably, for VHF and UHF, it's probably the most important factor. Now, Some people, for instance, put an antenna on a mast and they have a very long coax cable that goes from their radio to the antenna on the mast. And that's not the best solution because you have a lot of losses in the cable. That's where you have to buy very high quality cable, especially if you're on VHF and UHF, once again, because the losses are higher. It's much better to get your station, your radio, up high. Go on a mountain, on top of a hill somewhere. That's much better to use than using a mast or tower with a long cable. And height is very important because you also have the Earth's curvature that causes problem that comes into play if you have, let's say, two people that are 6 foot tall away from one another and they have handheld radios like this one. Well, at about 7 miles, their signal is going to hit the ground. So you'd have a range of, maximum 7 plus 7, or a little bit less than that. That's 14 miles. I would shrink that to about 10 miles. And that's where, that's the maximum range basically for antennas that are both situated on the ground. Remember, height is might. So I mentioned that regional communications are the most difficult. So near and far regional, meaning from 10 to 500 miles. Now there is a special technique that you can use to cover these ranges using the refraction on the ionosphere. The problem is though, you don't want to shoot your signal very far so it skips and goes to a very long distance. You want to send it vertically so that it refracts on the ionosphere and just rains down in a regional pattern. And that's called NVIS, Near Vertical Incidence Skywave. Big name, but it's pretty easy to do. Basically, knowing again that the signal is emitted perpendicular to an antenna wire, you're just going to flip your antenna horizontally. Now that only works on lower frequencies, mainly below 10 megahertz. It happens higher, but it's not reliable. So below 10 megahertz, so the lower part of the HF band. What you want is to string your antenna horizontally so the signal goes up again and just rains back down regionally. And you can do that by putting your antenna fairly low to the ground. Usually I string my antenna from 6 to 8 feet high, and that works perfectly fine. I also generally use the 40 meter band, which is 7 some megahertz, and that also works very well. Now you don't want your antenna to be too high, because if it's too high, it's not going to bounce on the ground at the correct angle, and it's going to go basically at a lower angle, it's going to go too far. Here's a good illustration of this. Consider my thumb here to be the antenna and my computer to be the ground. I'm using it because it's slippery. If the dipole or the antenna is too high, you can see the signal here is shooting up at about 45 degrees. But if I lower the dipole, you can see that the signal goes up and ends up being practically vertical. So it is perfectly possible to reach regional communications, to reach a regional range with shortwave radio without too much trouble. And you can do that on 80 meter, 3.5 megahertz, 7 megahertz, 40 meter band, and the 5 megahertz band, the 60 meter band. And for that, of course, you need an amateur radio license, which is a great reason to get one. All right, I know that's a lot of material, guys, but bear with me. I'm going to talk about propagation now. There are a lot of misconceptions about propagation, what actually propagation is. And propagation is how the radio waves goes from A to B. Sometimes it's easy and sometimes it just doesn't go through. And it's not always simple to know the reason why. So the most common propagation is ground wave. Ground waves means exactly that. It's from A to B in a line of sight, meaning that the best conditions is when you could actually see the station visually. from point A to point B. And that's the most desirable condition, of course. The problem is that we often have obstacles in the way. And radio waves can go through some obstacles. Not a whole lot of it, but some material. The lower the frequency, once again, the better the penetration. The higher the frequency, the more bouncing around is going to happen. And that's why, for instance, often UHF is better in urban environments, because you have a lot of buildings that are made of concrete, reinforced concrete, metal, etc., materials that can reflect radio waves. While VHF, so a little bit lower in frequency, can be better, for instance, to communicate through wooden areas. Although it's certainly not the best for that, but it would work better than UHF, for instance. So that's why it's great to have a radio that has dual bands, VHF and UHF. That's a ham radio, of course, requires a license, but you have some radios that do not require a license. Most of them are actually, I think all of them that I know of, are single band radios. So you would need a couple radios to cover both of these scenarios. Then you have skywave propagation, and that's what the CB guys use, and gals. Skywave is actually skipping, what they call skipping. Basically, your signal is sent towards the horizon, but will skip on the ionosphere and comes back down much further away. And usually when I get one skip, I probably get about 1,000 miles. So it can go very, very far, guys. The problem is that when you skip like that, well, you skip, it's like a triangle, but the people in the middle are not going to be receiving your signal. Only the people that are at the other end of the rainbow, so to speak. So, it's a triangle rainbow, but you get the point. So it's very useful, but it's hard to predict. So you don't really know exactly where you're going to end up. The way your antenna is installed also can change that, can change the skip distance. Now, knowing that the signal is sent perpendicular to the antenna wire, so you have an antenna that's vertical, the signal is sent perpendicular. So of course, if you tilt your antenna, say you attach one end on a tree and then you make a sloping wire like that, you're going to change the angle of your signal. So you're going to change the length of the skip. Also, it can skip more than once. So you can have your radio wave skip on the ionosphere, refract on the ionosphere, come back down, bounce on the ground, and refract again on the ionosphere and go further down. And it's actually possible to send a signal like a little beeps, dits and das, using Morse code, for instance, and you're going to hear them like, I think it's a couple seconds later or something like that. So it's amazing the delay. The signal can go all around the earth and come back around, guys. And that's absolutely amazing. Now, it doesn't always happen. It's fairly difficult to obtain, but it does happen. And that's why I can communicate, and you could communicate with Australia, down under. And that's the only reason it works, because of the ionosphere, and that is dependent on solar activity. So the more solar activity, the better. Right now we are at the getting to the top of the solar cycle, which lasts 11 years, and it's going to be very easy to make those long distance contacts. And that's on frequencies that are on HF. VHF and UHF don't really do that. The lower VHF sometimes does up to maybe 50 megahertz, the 6 meter band. Those frequencies are, it's pretty high, so it doesn't happen very often. But, CB does sometimes. CB does skip, but it's probably the highest practical frequencies, and it's not very often. So CB does it, but I'd say it's not quite reliable. Not quite reliable enough, but if you want to have fun and be very excited when you get a long distance contact, that will do it. And then we have some exotic propagation modes, which I'm only going to get into one. It's called tropospheric ducting, and there are different types of ducting. Basically, your signal can refract on a temperature inversion, refracts on the temperature inversion, and refracts again on a lower temperature inversion, and then you get like a duct effect where your signal is bouncing and just will land somewhere else. That's not really reliable, although there are locations where it is, and temperature inversions are a common occurrence, and it does happen at certain times of day. So it is something that you could potentially exploit, but you're not going to know until you try. So it can refract on 2 temperature inversions, and it can also refract on a temperature inversion and bounce on the surface of the ocean, for instance. And there are other ways that it's possible, but that's basically the tropospheric, ducting propagation. Not something you can count on really, although in some places maybe. For that, you would use a directional antenna, most likely on VHF or UHF, but probably VHF, and probably a little bit more power. Which brings us again to antennas. Antennas are very important. It's basically the heart of your station. The antenna has to be a certain length, and that's dependent on the frequency. So longer doesn't necessarily mean better. The correct length means better. And the best antenna to combine efficiency and practicality are half-wave antenna. Now, I'm not going to want to get into too much detail here, but just note that a half-wave is better. And to calculate the optimal length of an antenna, you can use the formula 468 divided by the frequency in megahertz, and that's going to give you the length of the antenna in feet. Now you have to consider where you're going to feed that antenna, and if you take, for instance, the example of a dipole, you take your half-wave wire, you cut it in the middle, and you feed the antenna at that point, which is, you use part of the coax cable, you use the shield of the cable on one end, and the center of the coax cable on the other end, and that gives you a dipole. A dipole is the simplest and most often used antenna in amateur radio, and you can use it up to even UHF if you want. And the dipole is bidirectional, so if you have the antenna strung horizontally, basically you're going to transmit in 2 directions perpendicular to the wire. You also are going to transmit some of the signal straight up, and some of it will be lost down in the ground. Now, if you want to put a dipole vertically, you're going to transmit all around pretty efficiently, but the problem is practical because you have to feed the antenna in the middle and bringing a coax cable in the middle, and then you have to go a little bit horizontally, to avoid the effects on the down arm of the antenna, and then go back down further down to your station. So it's really not practical to string a dipole vertically. Although you can feed it at the end, but for that you need an impedance transformer, and that's beyond the scope of this video. But if you watch my other videos on the end-fed half-wave antenna, you're going to find a lot of material there. Now, of course, for little radios like that are VHF and UHF, you have one of those little rubber duckies, and that's a quarter wave. So you're going to say, well, it's not a half wave, and that's true. It's not a half wave, so it's not that efficient. So, and on top of that, there is a little spring in there, so it's actually reduced in size. Because for VHF, this antenna should be 19 inches long, not a quarter, so that's about half of this. Now, there's one thing you can do, is to add a wire to it. You add a same thing, quarter wave wire, so 19 inches. You connect to the negative pole of the battery, or to the outside of the antenna connector here, not the center, but the outside. You just put some wire around it, have to take the insulation off, of course, and put the antenna back. The wire will stay, stuck in there. And then you measure 19 inches, you cut it. And that's going to be your quarter wave here. Quarter wave here, you have a half wave antenna. Much better efficiency. And that's using the formula, of course, 468 divided by the frequency in megahertz. You can do the same thing for UHF, actually. And for any other frequency. Now, those are omnidirectional antennas. Again, the signal is beamed, transmitted, radiates perpendicular to the antenna. One thing to consider is that if you're talking to someone else, you have your radio like this with the antenna straight up, and they are using it like this, you're going to lose a lot of signal. It's not going to work well, guys. From, close by, it's going to work, but if you're very far away, you need to either both hold the radio like this or both like this. And if you hold it like this, they better be over there and not this way, not aligned with the antenna, because you have a null here. It's not transmitting this way, it's transmitting perpendicular to the antenna. So something to keep in mind, because that will greatly affect your range. Now, there are antennas that are directional, so they will beam your signal in one direction only. And some other antennas also that can kind of squish it, so that it goes a little bit further. Now, I'm going to talk about Yagi-Uda antennas, and people often omit Mr. Uda. Yagi was more of the marketer of the, I think, of the Yagi-Uda antenna, and Uda was the technician. Although I don't know, they probably did a bit of both, but Yagi-Uda, not just Yagi. And those are the antennas that use like a, that look like, they have a I could say call that a beam. And you have elements that are, they look like, they're TV antennas. Lots of TV antennas are Yagi-Udas. And, they look like that with, different elements. And those antennas have a lot of gain. They don't amplify your signal, but they squish it basically into a certain shape, and they send it in one direction. So you don't have more power, but it's more concentrated. So at the end, it kind of looks like you have more power because, of course, it's concentrated. So it gets much further, and you can get a lot more range with a Yagi-Uda antenna, and they are very often used vertically and horizontally, both. But of course, the other antenna at the other end needs to be in the same orientation, so same polarization, that's what we call it. And there are others, directional antenna, like quads, Moxon. I mean, there's just a bunch of them which have different particularities, and it's beyond the scope of this video to study directional antennas, but watch my videos, you'll see a bunch of them. So the lower the frequency, the longer the antenna. Again, for these, VHF is the lowest for this radio, so 140 some megahertz. The antenna half wave should be 1 meter long, just about, which is about 3 feet long, because it's the 2 meter band, so half wave, 1 meter. And it kind of naturally is, because, well, this part is a real quarter wave that I added, and this is a fake quarter wave. Basically, it's kind of reduced in length because of the coiling in there. But basically, this is a half wave, electrically it's a half wave antenna. And it's fairly short. I mean, I can carry this, put it in my pocket somewhere, and it's practical. I can use that. It's not a problem. If you go lower in frequency, let's say you want to use NVIS to have regional communications, you're going to have to go down to, say, 7 megahertz, so the 40 meter band. Well, that means a 65-foot antenna. You're not going to put that, with a whip on your pocket and stuff. It's harder to set up. Of course, if you're in the woods somewhere and, it's the end of the day, you're setting camp or something, or you have a big garden, a long one, it's easy to set up a dipole or an unfed antenna that's 65 feet long. It's not a problem. And that's how you obtain the best results, basically. You could even go down to the 80 meter band, which is 3.5 megahertz, and you'd have a 132 feet antenna. And that's pretty darn long. Now, for portable stations, again, in the mountains or in the woods, like I do sometimes, it's not a problem because you have a lot of space. But here I live in an apartment, so I can't string 132 feet of wire from my balcony. It's just not gonna, they're gonna see it and someone's going to complain. But I use a magnetic loop antenna. That's something else. Again, watch my videos. But just so you know, that's why the antennas on those little walkie-talkies are short. It's because the frequency is higher. And putting a long wire, on this, it's not going to work. It's just not the correct length. The antenna has to be the correct length. Again, longer doesn't mean better. All right, moving right along. Don't worry, we'll get to the end. Output power. There is a lot of misconception about output power, a lot. And that's why people buy amplifiers, which to me are useless, but, to each his own. You don't need much power to make contacts, guys, even long distance ones. I once made a contact. I remember I was in Florida and I contacted a station in Estonia, Eastern Europe, using 1.3 watts, using Morse code, CW mode. That's a very long distance for not much power, but it's possible, and it all depends on your antenna and the mode you use, and we'll get to that too. But you don't need a whole lot of power. I told you about my friend who made a contact with 100 milliwatts with one of these, a similar walkie-talkie, 200 miles. It's not the power, it's the conditions and the antenna, the propagation, a lot of things that you're starting to realize. So don't worry about the output power when you buy a radio. If your radio, the radio that you see for sale or something, outputs 20 watts and the other one next to it outputs 50, doesn't mean anything at all. It's not important. It's not going to make a difference. If you have one of these and it's 5 watts, the one next to it is 10 watts, most of the time, you're not going to see any difference between the two. Okay, it's not what matters the most. All the other factors are more important than output power. There is a minimum of power required, but more than the minimum is not necessary. You can take the case, for instance, of the military man-pack radios. They all output between 25 to at most probably 50 watts. Probably most of the time it's 25 to 30 watts. Why is that? Because it's enough. You don't need more than that. They make extremely long distance contacts with these radios. And the military has pretty much unlimited funding. They can test stuff. They can buy whatever the hell they want. The problem with more power, it means bigger batteries, more weight, more current draw. It's just wasted, guys. It's not the most important factor. Which brings me to the fact that you do not need an amplifier. And I'm talking to you CB guys. You don't need an amplifier. An amplifier causes a lot of problems. It can amplify harmonics, frequencies that are multiples of your frequency, and pollute the airwaves and cause a lot of trouble to a lot of people. Especially the Italian, CB amplifiers, just stay away from those. Those can cause lots of trouble, then not worth it, guys. You can make extremely long contacts with the regular legal power on a CB. I'll give you another trick later when we'll talk about modes to go further, basically, but an amplifier is not the best way to do that. The best way to do that is a better antenna. Because an amplifier will not improve reception. On the contrary, it will hamper reception. And that's a big problem. While a good antenna will increase your signal strength and will increase your reception as well. And that's what you really want. So don't buy an amplifier. Use the money for something else. Go on vacation or something. And that's all I have to say about power. It doesn't take much. Now let's talk about modulation modes. It's a long subject, isn't it? There are different ways of sending a signal, information via radio waves. And there are voice modes, digital modes. Well, that's about it, isn't there? Voice and digital. Morse code also, well, it's kind of a digital mode, but it's CW mode, continuous wave. That's what we use to send Morse code. But most commonly used are voice modes, and there are different types of voice modes. Of course, you know AM, FM, used for music broadcasting because of the quality of the sound. Now, the problem is that some modes are wider than others. And what do I mean by that? Well, first let's consider the tone of your voice. When I speak here, I have low toned oh. I'm not going to do the high tone, guys. I'm not good at it. But you have middle tones and higher tones. So and that information all has to be conveyed through radio waves. So the more broad spectrum that you have, let's say an opera singer could broadcast a wider signal than I can. I don't have the range of singing. I can't even sing. I couldn't sing to save my life. So basically, my range of frequencies in my voice are much reduced, as compared to an opera singer who can go much wider. Now, the thing you have to consider is that output power of a signal is kind of is more a volume than a level. So when you have a signal, it looks like, you have, I'll put a picture on, has, different, you have you have much less lower tones, you have less higher tones, and you have a lot of mid tones. Okay. All that makes a volume. Now, if you increase the width of the volume, the width of the signal, you're going to increase the volume, But, for a given volume, so because you have a given output power, let's say 10 watts, if you have to fill a narrower signal, the volume, the level will be higher for the same volume. If you have a signal that's wider, well, your level is going to go down for an equivalent volume. So basically, a narrow signal will output at a higher level than a wide signal. And that's important because, for instance, AM amplitude modulation is about 6 kilohertz wide, so 6,000 hertz wide. FM is more than that, it's at least 12 kilohertz wide. So theoretically, FM wouldn't go as far as AM. Now, you'll ask, why do they use FM? Well, they use FM because of the quality of the sound. Now, AM isn't bad. It's pretty good. It was used to broadcast music for the longest time. But it was replaced by FM because the quality is better, but the efficiency is less. Which brings me to other modes like USB and LSB. Now, again, I'm not going to go into details, but those modes strip a lot of stuff from an AM signal. So we only use the upper sideband, which is USB, or the lower sideband, LSB. Now, you don't have to know all that, but what you should know is that the signal is narrower. And that's why it sounds a little bit like Donald Duck, You remove a lot of the information there. Your signal is narrower. It's only usually 2.5 to 3 kilohertz wide. And you lose a bit of quality, but you gain a lot of punch, so to speak. So your signal is going to be outputting at a higher level. So the mode can have an effect on the range. All of these walkie-talkies, pretty much all walkie-talkies except a few output FM. Now, it's great for voice quality, but it's not very good for range. Now, well, we have to do with what we have, but It's just not the best mode for one of these. Now I have another one, I don't have it on hand here, but it's the UV-K5-8. You can change the firmware and you'd have different modes, but I have a video about that. Well, I'm making a video about that right now, but you probably can find it easily once it's up. But just know that the mode you choose will make a difference in the range. And I'll go back to CB. Lots of CBs have AM and FM. For the longest time, I think it was only AM in the US, and it was AM and FM in Europe. I don't know about other countries, but and now FM is allowed in the US as well. But there are two other modes that are allowed on CB. It's USB and LSB. And as I just mentioned, those are better for long distance communications, especially when you want your signal to skip on the ionosphere. So if you get a CB radio, and you really should have a CB radio, because everyone has one, and if the SHTF, you'd be happy you have a CB, although it's probably better for local communications, not so good for long distance, global range, because it doesn't skip very often. But I would definitely suggest everyone to have a CB radio. But you should get a CB radio that has the USB and LSB modes, which both are called SSB, single sideband, so upper sideband, lower sideband. So make sure you have those modes when you buy a CB radio. And if you buy other radios, it's always a plus to have USB and LSB. Let's talk a little bit about digital modes, although it's probably not for beginners, but you have to know they exist because they can offer you unbelievable range. And that's done by connecting your radio to a computer via a sound interface. So you have the computer, the interface, and the radio. And basically you send digital signals. So it's kind of like texting, or sending text, typing text, and it's being sent to the other station. Now some programs have many more capabilities, especially JS8 call, and that's for the JS8 mode, which is probably, in my opinion, the best mode actually for preppers, or for anybody else for that matter. So have a look at that. It's unbelievable. A mode like JS8 can actually decode signals that are below the noise level, which means that you can't hear them on the radio because they are so low. And that's pretty incredible. So definitely a big plus for digital modes. The only thing that bothers me with digital modes, of course, is that you need to use a computer and you have all the cables and batteries and things that, recharging batteries and things like that. But really, it's possible to do it, and even in the field. And it's really the most efficient. There's just nothing better. My favorite mode, though, is CW, continuous wave, and that's what is used to send Morse code. Now Morse code has a long history, of course, and some people believe it's a dying mode, or it's no longer used, but I can tell you there are a lot of people using Morse code, and for good reasons. It's very efficient. The radios are small, they are simple, they have great range. For instance, about the efficiency, 5 watts CW is equivalent to about 100 watts in a voice mode. So you can see there how efficient that is, because of course it's only a tone, so the signal is very, very, very narrow, and of course all the power goes into sending that tone. It's a little bit like using a laser pointer as opposed to a flashlight, if you can imagine that. So it's my favorite. I love it. What can I say? It's efficient, it's elegant, it's the essence of radio, and that's my opinion, and I use it all the time. So very well worth learning, even if it can be frustrating sometimes. All right, let's put it all together now and see the frequency, the bands, propagation, and ranges. So if we look at HF, high frequency, so basically shortwave, It will work with ground wave, skywave at all ranges. So HF does everything, guys. Everything. If you have an HF radio, you can do local to global. It's not a problem. But the antenna is fairly long. If you go lower in frequency, you can have very long 65, 132 feet antenna. So something to consider. It's not something you're easily going to use for local communications. So although you should have an HF radio, you should have also a VHF, UHF radio on top of that, just to make sure that you can cover all your bases. Then you have VHF. VHF does ground wave, ducting, and it is good for local to near regional range. Now, near regional is not easy because you will need a directional antenna, but it's possible. And sometimes when you get tropospheric ducting, it can go extremely far. But those it's rare. It's rare. It's not. You can't rely on that. So you have to reserve VHF for local and near regional communications. And again, for near regional communications, it gets complicated. Then you have UHF. UHF is good for local communications, and it's actually good for urban communications. VHF is probably better for the countryside, and it will do ground wave, ducting, and is good then for local to near regional. And it's probably better to have a radio that does both VHF and UHF. But that would be a ham radio. Again, you'd need a license. But it's pretty easy to get, so don't dish it. Then we have VHF and UHF can sometimes go further, like I said, with a directional antenna. But again, it's not really reliable. So you can count on that. For regional communications, I would prefer NVIS using a near vertical incidence skywave on a band like 7 megahertz, 40 meters, or 80 meters, 3.5 megahertz. And that means a very long antenna. All right, we're getting close to the end. Let's see the different types of radio that you can get. First is amateur, so ham radio. Those radios can cover a lot of frequencies. Some cover them all practically, HF, UHF, and VHF. Most of them cover HF. And, if you get the walkie-talkies, they usually cover VHF and UHF in the same radio. So it's really, again, you should get your license, guys and gals. It's not hard. I mean, you can start in the US with the technician license. I'm not sure about the other countries, but it's pretty darn easy. I would even shoot for extra, because you have, in the US, you have a technician, general, and extra. But what I did is that I bought the 3 books from the ARRL, and I studied each, chapter 1 of book 1, book 2, book 3 on day 1, chapter 2 of book 1, book 2, book 3 on day 2, etc. until I finished the 3 books a couple of weeks later. I didn't think I would pass more than general, but actually I took all the 3 exams in the same session, and I passed them all. I got my extra license. I really didn't think I would. So something to try. Don't stop yourself at technician. If you get technician, you'll only have access to, some frequencies on HF, but mostly VHF, UHF. If you get general, at least, which is barely more material to learn, you'll get access to HF bands, and that will open the world for you. So give it a shot. You'll thank me later. You'll be very happy you did. Then we have CB. I started with CB, and I still love CB. I have a CB in my truck. It's a legal one. It doesn't go over the frequencies, that you're supposed to use. And it doesn't have extra power or an amplifier, because that's, again, it's useless. Okay. It has a good antenna, though. Very long one. That's quarter wave on 27 megahertz. But CB, in my opinion, is really good because it's the upper HF. So it does skip sometimes, It's not very often, but sometimes you'll make transcontinental communications with CB radio. It happens regularly, but you can't count on it. It's just not something that's, if you could be months without making a long distance contact if the propagation doesn't cooperate. If you are down in the solar cycle, sometimes it's extremely long between contacts. And I mean, I say month, but it could be years. Something to consider. It's great to have a CB though, because everybody and their cousin has one. And if, they probably have a CB in a closet somewhere in the garage, and something they haven't used for years, since the 80s. So, I'd say buy a new one, but it's really good because it's good for local communications. You don't need a license. You can make very long distance communications. It's good for the countryside. They don't have many handheld, walkie-talkie CBs, but they do exist. So keep that in mind. And basically, it's going to be to enable you to listen to a lot of people. And if society collapses, you'll be very happy you have a CB radio. And again, not if you really don't want a license, you don't have to. Then you have MURS, MURS for the US, and that's VHF. That's 150 or 50 some megahertz, if I remember well. It's just a few channels. I think there are 5 or 6. Can't remember, but there is no license, and it's VHF, so good for the countryside, and again, no license, so it's just a regular walkie-talkie, and it works really, really well. So not a lot of people use MURS, so probably good if you want to remain kind of hidden, keep a little bit of privacy. You won't have many people that are going to listen to it, so not a bad option. Then we have FRS, Family Radio Service, in the US. It's UHF. It's 460 some megahertz. Can't remember exactly. It's not important, but it's UHF, and you're limited to 500 milliwatts, or half a watt, and you cannot remove the antenna from the walkie-talkie. So you are somewhat limited in range, although it can go pretty far. I know on those little blister packages, you'll find at Walmart or other places like that, they say, 30-mile range or whatever. And they're not really lying. But what they don't say is that usually it's going to be more like a quarter mile, in most situations. But if you go on top of a mountain, yeah, sure, you can do 30 miles, probably even, more than that. But it's not going to happen very often. So, but it's a good option for close range communications, and they're cheap. You can give them to your neighbors. You can, you can buy a bunch of those and give them to people. Make sure you buy the kind that you can recharge by a USB cable, a mini, micro USB or USB-C. Now you can find radios that are rechargeable by USB-C, which means that you can use a solar panel, a pretty small solar panel, and recharge those radios without great power. So something to consider. But you don't need a license, and they are fun to use, and they can be extremely useful if the internet and the phones aren't working anymore. In Europe, the equivalent to FRS is PMR, so it's 466 megahertz. Same thing, so 500 milliwatts limit, antennas you can't change, and they serve the same role basically, so it's just the same thing. Then I'll talk about another mode that doesn't require a license, and it's a digital mode, and it's Meshtastic. Meshtastic is fantastic. Oh boy, that's so... Anyway, that's probably how they got the name, but Meshtastic, and I've just ordered a couple cards there to use. Meshtastic is basically a little device. It's very small. It has an antenna on it. It works on 868 megahertz in Europe and 915 in the US. I don't know about anywhere else. But basically, it's a little device that you pair with your phone or your smartphone via Bluetooth, and you can send text messages to another person that has the same device. Not only that, but the devices make a mesh network, meaning that if you're too far from your destination station, if there are other Meshtastic devices in between, they will relay your message to the destination station. And that's amazing because you can have absolutely great, very long range with a device that's really not made for that, but using that mesh function, it can use other stations to relay that message and cover a lot of ground. It probably, I'm thinking that at the way this system is evolving, the speed at which it's evolving, it would probably be possible in some cases to cover the whole United States or the whole of Europe with one of those devices. And I'm very excited about trying it. I've ordered 2 of them. I'm probably going to order a few more. And look it up. It's extremely interesting. It's simple to do and doesn't require a license, and it's very long range. All right, so I think that covers it all. Whoop, don't click stop. I'm not finished yet. If you found this video interesting, consider helping the channel with Patreon or the coffee donation link down below. There are also crypto addresses there. Also join we have a Facebook group. It's Radio Preppers. And of course, this channel. Like the video, share it, please share it, and subscribe to the channel. Lots of people aren't subscribed, so if you like the video, please do it. Just as a thank you, and I really appreciate that. Don't hesitate to ask questions about this on radiopreppers.com or the Facebook group, or in the comments on this video. And I'll answer to the best of my ability, and maybe other people will. And that's the end of this video, guys. I hope it was worth it. Have a good one. Alright, because this website does cost me much more than what it brings me, I did sign up for an affiliate program with EMP Shield. We are all concerned about EMP's, electromagnetic pulse, especially for radio equipment. And EMP Shield does provide protection for your whole home, for your vehicle, and for your radios. Yes, for your antennas. I was a bit skeptical, I have to admit, but after looking at all the documentation they have and the military testing they did, and those devices they offer are extremely fast to protect you against EMPs, but also, of course, lightning. So it does look pretty legit to me. I got you a coupon for $50 off at EMP Shield, so don't forget to use it. It's Radio Prepper in one word, all lowercase. By the way, do use the link down below rather than going to the site directly. That gives me more brownie points. And you do save $50 and I get a kickback. So don't hesitate to have a look at their website. I am learning more about it myself and all the products that they offer. And I'll tell you, the way the world is going right now, I think it's a good precaution. The solar cycle is coming back and there will be a lot of solar activity. So we could get a natural EMP that's always a threat. And you want to protect your electronics. Your toaster, your washing machine, your oven, everything that has an electronic chip in it is at risk. And you need a device that's fast enough to ground everything in nanoseconds so that when the power comes back, you still have your electric and electronic devices. Once again, the coupon is Radio Prepper, one word, lowercase, and that will give you $50 off.